Welcome to this spoken tutorial on simulating a plug flow reactor in DWSim. In this tutorial, we will learn to define a kinetic reaction, simulate a plug flow reactor, calculate conversion and residence time for a reaction in a PFR. To record this tutorial, I am using DWSim 4.3 and Windows 7. The process demonstrated in this tutorial is identical in other OS also, such as Linux, Mac OS X, or Fuzzy OS on ARM. To practice this tutorial, you should know how to add components to a flowsheet, how to select thermodynamic packages, how to add material and energy streams and specify their properties. The prerequisite tutorials are mentioned on our website. You can access these tutorials and all the associated files from this site. We will develop a flowsheet to determine the exit composition from an isothermal PFR. Here, we give reaction, property package, and inlet stream conditions. Next, we give reactor parameters and reaction kinetics. I have already opened DWSim on my machine. Go to File menu and select New Steady State Simulation. Simulation Configuration Wizard window appears. At the bottom, click on Next. First, we will add the compounds. In the Compounds Search tab, type nitrogen. Select nitrogen from ChemSafe database. Similarly, add hydrogen from ChemSafe database. Next, add ammonia from ChemSafe database. Now, all the compounds are added. Click on Next. Now comes Property Packages. From available property packages, double-click on Peng-Robinson. Then, click on Next. We are moved to Flash Algorithm. From Default Flash Algorithm, select Nested Loops VLE. Click on Next. Next option is System of Units. Under System of Units, select C5. It has the desired system of units according to our problem statement. Then, click on Finish. Let us maximize the simulation window. Now, let's insert a feed stream that enters the PFR. On the right-hand side of the main simulation window, go to Object Palette. From Stream section, drag and drop a material stream to the flowsheet. Click on Material Stream MSTR000 to view its properties. Let's change the name of this stream to Feed. Now, we will specify the feed stream properties. Under Input Data, select Flash Spec as Temperature and Pressure, if not already selected. By default, temperature and pressure are already selected as Flash Spec, so let's not change it. Change temperature to 425 degrees centigrade and press Enter to accept the new value. Change pressure to 200 bar and press Enter. Change mass flow to 3600 kg per hour and press Enter. Now, let us specify the feed stream compositions. Under Composition, choose the basis as mole fractions if not already selected. By default, mole fractions is already selected as basis, so let's not change it. Now for nitrogen, enter the amount as 0.5 and press Enter. Similarly, for hydrogen, enter it as 0.5 and press Enter. For ammonia, enter 0 and press Enter. On the right, click on this green tick to accept changes. Now, we will define the kinetic reaction. Under Tools, click on Reactions Manager. Chemical Reactions Manager window opens. Under Chemical Reactions tab, click on the green-colored Add Reaction button. Then, click on Kinetic. Add New Kinetic Reaction window opens. First part is identification. Under identification, enter the name as ammonia synthesis. Next, enter the description. Irreversible reaction for the synthesis of ammonia from nitrogen and hydrogen. Next part is a table of components, stoichiometry, and reaction orders. First column, name, shows the available components here. Second column corresponds to its molar weight. Next column is include. It indicates the components which will take part in the reaction. Under include, check all the checkboxes against all the components' name. Fourth column is BC. It indicates the base component of the reaction. Under BC, check nitrogen checkbox as nitrogen is the base component. Next column is stoichiometric coefficient. Under stoichiometric coefficient, enter -1 for nitrogen, -3 for hydrogen, for ammonia 2, and then press enter. Negative sign is to indicate the components as reactants. In the stoichiometry field, we can see it is showing OK. So, the reaction is balanced after entering the stoichiometric coefficient. Here, the equation field shows the reaction equation. Next column is DO, which indicates direct or forward reaction order. We are considering the reaction to be the first order with respect to nitrogen. So, we will enter 1 in the DO column against nitrogen, and then press enter. Next column is RO, which indicates reverse reaction order. Since we are considering an irreversible reaction, we will not enter anything here. Then comes kinetic reaction parameters. Our rate is in terms of molar concentration. So, we will select basis as molar concentration. Select phase as vapor. Next is Tmin and Tmax. It gives temperature range within which rate expression is assumed to be valid. So enter Tmin as 500 and Tmax as 2000. Now go to direct and reverse reactions velocity constant. In direct reaction, enter A as 0.004. Click OK and close Chemical Reactions Manager window. Now, let us insert a plug flow reactor into the flowsheet. Go to Object Palette. Under Unit Operations, click on Plug Flow Reactor. Click on it and drag it to the flowsheet. Let us now arrange it as required. We will insert one output stream. To do so, drag one material stream. Let us once again arrange it. As this is an output stream, we will leave it unspecified. We will change the name of this stream to product. Next, we will insert one energy stream and name this stream as energy. We are now ready to specify the plug flow reactor. Click on it. On the left, we can see a tab displaying properties related to the PFR. This tab is called Property Editor window. Under Connections, click on the drop-down against inlet stream and select Feed. Next, click on the drop-down against outlet stream and select Product. Then, click on the drop-down against energy stream and select Energy. Now go to the next section, Calculation Parameters. Here, the first option is Reaction Set. By default, it is Default Set. Since we have only one reaction, we leave it as it is. Next, click on the drop-down against Calculation Mode. Select Isothermic. Then click on the field against Reactor Volume and enter 1 meter cube. Then press Enter. Click on the field against Reactor Length and enter it as 1.5 meter. Then press Enter. Now we will run the simulation. So, from the toolbar, click on Solve Flowsheet button. When the calculations are completed, click on PFR in the flowsheet. From the Property Editor window of PFR, locate Result section. Under General tab, check residence time. It is 0.013 hour. Under Conversions tab, check conversion for both the reacting compounds. For nitrogen, the conversion is 17.91%, and for hydrogen, it is 53.73%. Now, we will check the material balances. Go to Insert menu and select Master Property Table. Double-click on the Master Property Table to edit it. Configure Master Property Table window opens. Enter name as Results Plug Flow Reactor. Enter object type as Material Stream. By default, Material Stream is already selected, so we will not change it. Under Properties to display, select object as Feed and Product. Under Property, scroll down to see all the parameters. Now, select the properties as Temperature, Pressure, Mass Flow, Molar Flow, Vapor Phase Volumetric Fraction, Molar Flow Mixture Nitrogen, Mass Flow Mixture Nitrogen, Molar Flow Mixture Hydrogen, Mass Flow Mixture Hydrogen, Molar Flow Mixture Ammonia, Mass Flow Mixture Ammonia. Close this window. Move the Master Property Table for better visibility. Here we can see the corresponding results for product and feed. Let us summarize. In this tutorial, we have learned to define a kinetic reaction, simulate a plug flow reactor, calculate conversion and residence time for a reaction in a PFR. As an assignment, repeat the simulation with different compounds and package, different feed conditions, different PFR dimensions and reaction kinetics. Watch the video at the following link. It summarizes the spoken tutorial project. The spoken tutorial project team conduct workshops and gives certificates. For more details, please write to us. Please post your time queries in this forum. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSim. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team coordinates conversion of existing flowsheets into DWSim. We give honorarium and certificates for those who do this. For more details, please visit this site. Spoken Tutorial and FOSSEE projects are funded by NMEICT, MHRD, Government of India. This tutorial is contributed by Kaushik Datta and Priyam Nayak. Thanks for joining.